Hello, this is That Rob Human, and this is part 5 of my Tabletop Playground development series. In this episode, we're going to be going over the image shape model and the dice objects. I don't have much preamble this time around, except to say that I've added some textures and models to the repository, which will be downloadable, link in description, so on and so forth. We'll be using them throughout this, so we'll dive into that in just a minute. I'm going to go in and edit this package, and I'm going to create a new object, and we're going to begin with talking about the image shape model. And there's actually not a lot to cover here, and the reason for that is because the image shape model is just a variant of the generic template. Just like how cards and tiles and tokens are identical, so too is the image shape model. The only difference is what is it starting with. If you recall, when I talked about the generic model, one of the options is you could use a shape texture, like a transparent texture, to define the model shape. This basically just assumes that that's what you want to do right off the bat, so it's just another option to get a generic model. So I'll actually go ahead and just create one out of one of the textures that I have aligned here, and we'll hit create. And you'll see it's actually just a generic model. All it's done is activated this switch and set the texture to use that silhouette. I can actually change this texture to be, I don't know, this reverse thing. So it will, it's interesting that you can still do that. But it will also just map the outer edge as the primary color. But you can continue to use, textures as you would otherwise. In this case, I've actually made a bit of a mistake here. But yeah, it's basically just a generic model. I wonder where that mask token is. That mask that I just unselected. That might be a bug. I might actually submit that as a bug. But like that's the benefit of using an image shape model. If you have just a transparent 2D projection of your 3D model instead of the 3D model itself, you can use this to actually create a 3D model from it. But again, you can just do that with a generic model and go that way. And to create the generic model, and just for the sake of consistency here, if I go into the generic and pick an object sphere just to get in here, or the debug cube, I can actually just turn this on and select that same card texture as my 3D model, and there it is. The only difference is that it's rotated. So that's a thing. And it tints the whole thing. So maybe that is actually the only major difference, is that you can say with the image shape model, don't tint textured parts. That's what let it tint the edges and not the faces. I don't know if there's a way to get that back if you actually unselect it. I'll submit a bug about that. But that's basically image shape models for you. Dice, however, are far more interesting. Now, as it says right in the tooltip here, you can select one of their templates, and you can use that as the basis for your dice, and they're fairly explanatory. You basically just create the D4, you select a texture that maps to their UV map set that is found in their knowledge base. To get to the knowledge base, by the way, you can either just Google it, or if you go back to the main menu, there's a link down in the bottom right corner for their Discord and the knowledge base, so you can find it on there. But in our case, we're going to go and skip straight to the advanced version and create a die straight from a 3D model. So I'm going to create it, and obviously there is no 3D model to look at because I haven't had one selected. So we're going to do this, D6 round mesh. And you can see it's a D6 with rounded corners. D6 die. Okay, so, you know, not very die-like right now, but that's okay, we'll get to that. So, what I'm going to do is I'm going to just cook for a second. So I'm going to do texture. And this is going to be a little bit of an exploration on what I can do with fancy masks and stuff. What's this? Dice. We want X. See, there we go. Let's make that, I don't know, gold. And you might think that looks good, right? Well, let's have some more fun with this. I'm going to make this transparent. Okay. Don't cast a shadow. Not two-sided. And we're actually going to do... You know, I'm just going to copy this because we want to do this from here. FF674F. And that's EDAA24. I'm just pulling the values that were there. So this kind of ghost die. Not that great looking. So I'm going to add another model. And we're going to use, let's see, which one do I want? I'm looking at my notes because I've done this before. We're going to use this one. You can see it's got some weird fracture shapes in it. Might already be a hint of what I'm doing, but just trust me. It's got no texture. Cool. This one we do want to be solid. Okay. We don't want to... We want it to not override, and we're going to just go for like you and this for now. And we're going to set a normal map. Dice gem n. That doesn't look all that interesting yet. It's okay. Let's do a mask map. Dice gem x. That doesn't look all that fascinating yet either. Again, that's okay. Let me cook. Let me cook. We're going to turn the roughness all the way down to like 0.02. And we're going to turn the metallicity like about there. And you got some glimmer going on now. Right? Right? You with me? Okay, I'm going to swap back to this one. Play with our roughness a little bit. And if you recall in the first model, or the first series of this where I talked about the generic model, how you probably want metallicity to be either 0 or 1. This is one instance where I found it to be helpful that it's not. So what I've got here is this is altering, if you look at the specular highlight right here, this is changing whether or not it kind of, the color of that highlight, and roughness is going to change the size of that. So I'm going to go for about there. Okay, cool. And now it occurs to me I'm missing a normal map. So we want that to, yes. Okay, so now it looks like it's indented. That's more what I want. Excellent. Okay, so I've got this outline and I've got this shimmery fraction, like fracture thing going on. Change the colors of this a little bit. I want it to be more orangey, because why not? Yeah, it's kind of pixelated and ugly looking, but yeah, just bear with me. It's okay. Trust me. I'm going to create one more model here, and this one I'm going to use the inverse. Hopefully this will work. Good, and that kind of solidifies the back side of that. So if I remove that, you can see how that... And this is the same cube, by the way, just with the normals inverted. So it's pointing backwards. It's not transparent. Good. On this one, we're going to use that same gem N, or that gem normal map. Oh, it looks like it's a little fractured in there. That's good. We'll use gem X for the mask map. Okay. We're going to disable the overrides. Strictly speaking, I don't necessarily need to just skip the overrides. I could just have everything colored by the primary, but like, that doesn't seem fun. Cool. Turn the metallicity all the way up and the roughness to like 0.2. So as you can see, you get this really nice gemstone effect. More or less. Like, it's a little rough, but like within the confines of what I can do in 3D model in this particular material system, it's not bad. So yeah, that's kind of what I have. I'm actually going to change that to a silver instead. So that's what I have in mind. Like, there's my die, and it shimmers in the light and whatnot. But, I mean, right now it's just a really fancy cube, right? Well, over here on the right, you'll see there's no face directions. Huh, interesting. By default, in DICE, it looks like it adds metadata. So, I am actually going to change this. Oh, you know what? No, this is actually fine. The default collider is perfectly fine. Not going to worry about snap points now. So, this last panel off to the right, this is what determines the value of the die that you're rolling. So when you go to roll it, it's going to come up with a certain value. And, well, how does the game know what that value will be based on the direction? Well, this is where you add that. So I'm actually going to hit add. So we've got a face with a name of 1, and it's got these XYZ parameters here. Now, a good way to deal with this, by the way, is if you just turn on the face direction, it'll tell you which face you're actually looking at right now. This XYZ is basically a vector that is pointing in the direction from center of mass to the face that is highlighted. So this first face is currently pointing towards 3 when we actually wanted to point towards 1. So to do that, it's really simple. We're just going to change the Z direction to 1 and the X direction to 0. And now it's pointing straight up. That's pretty much it. I'm going to, now if we wanted this to say, well, let's create a new face. That's not, we want, nope, -1. Excellent. See, and that'll be face 2. We can actually just copy that, change that to 3. And 3 is going to be 1, 0. So yeah, it's just a vector, a look at vector. It gets a little bit more complicated, obviously, with polyhedral die that aren't cubes. Cubes are simple, comparatively. And it's kind of why I did it this way. And this is going to be 1 and 0. And then one more. We're going to do 1, -1. And that's your dice setup. Now, if you're doing like a D10 or a D6 or a D4, or not a D6, a D4 or a you know, a D20 or something, you're gonna have a lot more faces, and the vectors that you're gonna plug in are gonna be a little bit more complex. But I mean, it works the same exact way. For those who are familiar with 3D modeling, you basically just want to point in the normal of the face that you want to use. So like, obviously this is a face, a polygon. You just, what's the normal of that face? You just plug that in for that, and that'll work fine. It is possible I actually have these all reversed. I can't remember if it points towards the face or points towards the ground when you want up. I can't remember. We're about to find out. So I might need to come in here and actually flip all the vectors. not a big deal. And likewise, just like we did with cards, every face has their own metadata, so you can actually look up the metadata for any face or the metadata for a face that is currently up, so you can access that. The other thing you can do is actually you can, instead of giving it a number, and if this is a number, it will add up all the die results and whatnot. So like if you roll, I don't know, I mean, let's just try it, right? I'll come in here and preview it, and I'll show you exactly what I mean. I can't imagine it's that much of a leap of logic, but, you know, give it a try. 4. Excellent. So if I actually come in here... Oh, my mouse sensitivity is way too high. Where is it? Camera drag sensitivity. We're just going to turn that way down. It's better. Okay. Hit R to roll it, and there we go. 5, 4, 6, and 2. 5... Right. 4 dice of 1. Sorry, 1 die of 4, 1 die of 5, 2 die of 6. Gives me 21. Cool. But you're not necessarily just constrained to numbers. You could... I'm going to just right-click and edit this template and be like, hit. Miss. 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 Hit. And for the 6th one, we'll do critical hit. Because why not? For all you Fantasy Flight Games fans out there, you'll probably be using symbolism for this. So that's a handy thing. So if I roll these, well, now I've got 1 critical hit, 1 miss, and 2 misses and 1 hit. Now, obviously, I don't have the symbols on there to represent what they all are, but you can see it does the math and adds up based on the name of the die. So, when the name of the face is a string or a word, it will group them by that name, and when it's a number, it'll just group them and add them. It'll group them and sum them. So that's a helpful thing to know if you're doing specialty dice where it's not just numeric, but otherwise, yeah, that's pretty much all the special stuff for dice. The only thing I would say is if you are doing complex polyhedral dice, like a D20 or a D10, I would strongly advise having a model that is the fancy interpretation, with chamfers or rounded corners and all of that, and have the collision model be an exact copy of that, but without all the fancification. So like no chamfers, just straight up simple faces. It just makes calculation easier. In fact, I'll show you. I mean, it's not going to make a big difference because of the fact that it's already a cubic collider, but like this is my simple mesh, and it's basically the D6 without the rounded corners. So likewise, if I did a D10 or a D20, a icosahedron, I would have the fancy version of the icosahedron as my display model, but have just the 20-sided die icosahedron, or the 20-face icosahedron as the collider. At which point, you're basically just plugging in the normals for the icosahedron faces there for your face directions. So that's kind of how that works. The only other thing I would mention is if you're doing your own 3D model of dice, it is important to keep the origin of the model as the center of mass. So like in the case of, say, a D4, the center of mass is not the geometric center of the die. I would strongly recommend putting your model's origin at the center of mass, not the center of geometry. bit of a difference. It behaves a little bit better when you do it that way. So I would strongly recommend that. Otherwise, pretty much everything else is like any other model. It's just got this neat little face direction option. The other thing that actually I think is worth mentioning here, and I'm going to just back out of here. This is a bit of a hack, but I found it really useful. I'm just going to create a new die here, and I'm going to select our hexagon token from last time, and I'm just going to quickly blitz through setting up a texture for this, so bear with me just a second. Yep, cool. Tokens RC, and let's get fancy with it, why not? Okay, so we've got this what is essentially a coin, right? Now I'm going to add the collider in here just so that it's there, and cool, everything's good. So if I were to create this, a new face here, and give it one of these, one of the things that I could do here is I could make a D2, right? In fact, let's actually make this, I don't know, copper E. Let's just... Yeah, okay, copper E, sure. You could make a D2, so like I could add a second face and point that down, right? But one of the things that you can actually do as well... Why is this not letting me save? Oh, the name needs to be set. Coin 1. So there's actually no reason why you can't have more than one face have the same numeric value. So for 1, I can be like 1, and for the second face I can be like, that is also 1, and I can save that. I'm going to say coin 5, and I'll change this to, say, a slightly silvery color, sure, and we'll change this to 5 and change this to 5, and I'll hit save as new, cool, and I'll say coin 25, and I'll change this to a gold color, and we'll change face 1 to 25, and change this to face 25 and save as new. Okay, you with me so far? Gonna head back. I'll create a new empty table. Coin 1, coin 5, coin 25. This is how you do poker chips, because you can count them, because the two faces have the value that the poker chip represents. See? 6 tokens worth 5 credits each, 30 credits. Likewise, here's 150. Here's 6. And the only thing is that if you hit R, they'll start rolling as if they were dice, which is, that's fine. Turn it into a parlor trick. Flip the dice. Or flip the coins. But it lets you basically have poker chips. The other thing you can do here actually is you can add a snap point. And I'll turn that on so I can actually see them. And we'll do... Yeah, we don't care about the snap rotation. We'll make it a cylinder. We'll change the snap range down to 1. Sure. We'll hit save and apply to all. Go back. And this is only going to affect the 25, but you can see that's how you stack them. So now you have a stack of tokens. The only thing is that the physics can get a little wonky, so you might want to, tweak the physics, change the bounciness to 0, change density and the friction up way high. That'll prevent some bouncing a little bit. Yeah, it feels much more deady. Like it's not a perfect stacking, but you know what? It works. So that's a good way to get poker chips and poker stacks out of dice, of all things. That's a neat little workaround and hack that I've seen. So that should cover dice in its entirety here. Next up, I'll probably cover boards, and I'm kind of... I'll probably cover boards and cardboard figures after that. Card holders and containers are a little bit more complex. Multi-state objects are a little more complex. Books are relatively simple. They're just PDFs, so I'm not sure if that deserves a whole episode. I might lump that into these three. And tables, it's just a model. I might cover that. I don't know. But next up is probably card holder and or containers. It's probably where I'll go next. Anyways, enjoy. Give a shout if you need anything, or I don't know, say hi in the comments or something. Bye.